All right, so I'm going to be sharing my screen so we can get these notes going. All righty, so 9.2 deals with inverse functions. Okay, so first of all, we'll look at finding the inverse of a relation. And y'all, inverse is the undoing of an operation or the opposite of an expression. So to find the inverse of a relation is a set of ordered pairs. So to find the inverse of that relation, we exchange each x and y for each ordered pair. Okay, so let me write you an example here, and we'll find the inverse of the relation. All right, so they're giving me a set of ordered pairs. I got 0, 5, 6, -6, -2, 9, and 5, -5. So they're giving me my ordered pairs. So our answer here, MATLAB will give you the squiggly, curvy parentheses. All we have to do is put in our answer. And y'all, for the inverse of this relation, all we're going to do is come in and switch each of these x and y coordinates around. So the first one I had 0, 5. My inverse will be 5, 0. And then a -6, 6. 9, -2. And then switching my last one, I get a -5, 5. So the inverse of a set of ordered pairs, you just switch the x and y's around, and then you're done. Oh, did I lose everybody? Yeah, leave the signs the same. All right, so let me go back to share. My screen froze up on me. Oh, mine still froze. All right, y'all hang on a second. Let me see what's wrong with my camera here. Y'all be patient. I'm going to try to reload my camera. For some reason, it's not responding. All right, I'm going to try to reload it up real quick. Oh, it was still going for y'all? Okay, it froze on my end, so it wasn't showing me what I was writing. So, all right, so I'm back. It's back, so let me get it back on. All right, there we go. All right, y'all, this next example, they want me to find an equation of the inverse relation. All right, and they're giving me x to the third y equals -8. So same thing as I did up here on these ordered pairs. The inverse of this relation, all we're going to do is switch that x and y around. So the exponent stays, so that was an x to the third. Now it's going to be a y to the third x, and then that'll equal the -8. So notice all I did was switch that x and y and we were done. Okay. All right, but we're more worried about functions in this class than these little relationships. So let me give you the steps to finding the inverse of a function. So here we go, finding the inverse of a function. And remember, my functions were f of x. Okay, so we're going to find the inverse of a function. It's a little bit more detailed than doing those ordered pairs, okay? So the first thing we're going to check to see if it's 1-to-1. So is the function 1, 2, 1? And I'm going to show you in a second how we're going to check that. We're going to use what we call the horizontal line test to check that. So I'll show you. So if it's not 1-to-1, stop. Okay. But if it is 1-to-1, then continue. All right, so if it's 1-to-1, and I'm going to show you how to check that, then we're going to find that inverse. So the first step in finding the inverse is to replace f of x with a y. We put a y in there instead of f of x so we can actually solve these equations, okay? All right. Once I replace the f of x with a y, I'm going to do the same thing I've been doing all morning. We're going to switch the x and the y. So switch the x and the y. So at that point, we would have had y equals something. Now we have x equals whatever after we switch them. All right, once I switch that x and y, we're going to solve for the new y. Okay, so I'll solve it for that new y that I switched. So once I'm done solving that for the y, I've actually got my inverse function. So now we're going to use the function, the inverse function notation to write the answer. So the last step, we switch the y with f negative 1 of x. And this is what we call inverse notation. So f of x will be my function. F negative 1 of x will be my inverse function. Okay, y'all, and then we're done. So before I get into actually doing a problem, I'm going to explain what the horizontal line test is. Now, let me refresh you a second. We had a vertical line test where we ran a vertical line across the graph, and we were checking to see if it was a function because each of the x values could only have one y value. A horizontal line test is checking horizontal lines going down the graph because each of my y values can only have one x value. So 1-to-1 means each x has one y value, each y value has one x, okay? Can't have a choice either way on these. So the horizontal line test tells me that if it is possible for a horizontal line to cross the graph more than once, then the graph is not 1-to-1. Okay, so say I had a line going uphill left to right. If I was to run my horizontal line down this graph, notice everywhere on here it's only intersected my pencil one time. Okay, so 1-to-1 intersects it once. To not be 1-to-1 would be a parabola, right? Notice if I try to run a horizontal line down the parabola, it intersects it over here and over here. So the parabola is not 1-to-1, but this straight line is 1-to-1, okay? Usually you'll find out that things with even exponents are not 1-to-1, but we can restrict the domain to make it fit our actual problems if we want. So before I actually work those, I'm going to do an example or two on this horizontal line test. So I'm going to determine if 1-to-1 using the horizontal line test. In the future, I might call that the HLT, the shorthand. All right, so I'm just going to have a few pictures here. So there's my X and my Y. So y'all, this first picture sort of gradually goes uphill. And then sort of takes off uphill. So basically, I'm coming down with my horizontal. It's only intersecting me once everywhere I go. On my line, I'm intersecting here. Down here, I'm only intersecting once. And all the way through that, you'll notice my horizontal line only intersects it once, no matter where my horizontal lines are coming across. Okay? So no matter where I'm going across, I intersect it just one time. So this one is, yes, definitely 1 to 1. All right, I'm going to draw me another one right here to the side. So my X and my Y. So this one has what looks to be an upside down parabola. So I would check this one again with my horizontal lines. And y'all look at this. If I came across right here with a horizontal line, I'm intersecting my graph right here and right here. So it's intersecting the graph twice. So this one would definitely be a no. Now, if I wanted to do problems that involved parabolas, I would have to restrict the domain to where I said, hey, the X has got to be greater than or equal to 0. If I did that, then only this part of the graph would show, and it would be 1 to 1. But when you got the whole graph there, it's definitely not 1 to 1. All right, so we wanting to get into some of these actual problems, finding those inverses of the functions. So for these problems, we're going to determine if 1 to 1. If it's 1 to 1, then find the inverse. So usually what I do, I'm just going to graph them real quick on the calculator, see if they look 1 to 1, and then find those inverses. So my first one they're giving me is f of x equals x minus 9. So here we go. I'm going to graph that in my y equals real quick. So let me clear that. And I'm just going to put in my x minus 9. And then I want to see my graph to see what's happening with this. So I'm going to hit the graph button. And if y'all notice, it's making a, looks like a little straight line going uphill left to right. Which if you run your line down that, you can see it only intersects it once everywhere on that line. So this is definitely, yes, 1 to 1. So we're going to find the inverse now. So this is the trickier part of it. The first thing I said on that list of steps, we got to replace the f of x with a y. So this now becomes y equals x minus 9. So replace f of x with y. And then y'all, whoops, let me get my paper. Then I got to switch that x and y around. So we're going to switch the x and the y. So if I switch that x and y, this becomes x equals y minus 9. So y'all seeing the whole moral of the day is we switch x and y's when we find these inverses, right? All right, now what I want to do to this is solve for my y. Well, that y is right here. You got one move to get this y by itself. All you got to do is take care of that negative 9 sitting there. So I'm going to add a 9 to both sides. So y'all, here we go. This side gives me an x plus 9. The right side, the 9s are gone. All that's left is my y. So we have solved it for the y. And then my last step was to replace the y with f negative 1 of x. And I'm just flopping the sides around, y'all, because I want this x plus 9 to be on the right side so that I get f negative 1 of x equals x plus 9. So MATLAB gives you the f negative 1 of x. All you're going to be putting in are your answers you're getting on these, okay? Now, we'll tell you some things that you look for on inverses is you look for opposite operations. If the function had stuff being subtracted, the inverse will have stuff being added. If the function would have had stuff being multiplied, the inverse would have had stuff being divided. If I'd have had stuff being squared, my inverse would have had stuff being square rooted. So you'll always find counter operations on those, okay? So, do y'all have a question on this one? So let's do more. I think you'll find these not too bad after we do a few of these, okay? So I'm going to do this one really similar to that. This one's going to be f of x equals 6x minus 2. So y'all, let's go to y equals and let's draw this and see what it does. But y'all, we know anything with a single x like that is going to be a straight line when you draw it. So what I got, 6x minus 2. Let me graph that one. So it's a little steeper, but it's still a straight line going uphill. And if I come down with my my horizontal line, I can tell that I'm only intersecting it once everywhere I go. So this is definitely, yes, 1 to 1. So since it's 1 to 1, we will now find our inverse. So same steps, y'all. First step, replace the f of x with the y. So this is now y equals 6x minus 2. So once again, replace f of x with a y. So I sort of write the stuff I'm doing on the first view for sure. Next, we said we're going to switch x and y around. So if I switch that, I now have x equals 6y minus 2. So notice, the x had a number in front of it, but the number does not switch, only the variables, okay? All right, so now you got x equals 6y minus 2. You want to solve that for that y. So I think on this one, what I would do first would probably add 2 to both sides. That way I get the 6y by itself. So we get an x plus 2 over here. On this side, I can bring down my 6y and my 2's are canceled. And then finally, I'm going to need to make that a 1y, so I'm going to divide both sides by 6. And y'all remember, when you got two things on one side and you're dividing, you got to divide everything by that 6, okay? So this side does not simplify any because all three of these do not have a 2 in them. So since the x don't have a 2, that means we cannot simplify that. So that's going to stay at x plus 2 over 6. But the right side, the 6 is divided out, making a 1, so I get a 1y. So, y'all, we've solved it for the y now. So remember, my last step is to replace the y with my f inverse notation. And then that'll equal what? A x plus 2 all divided by 6. So that's what we'll put in MATLAB and be done, okay? Are you also ready? Next one, right? All right, so I'm going to turn it up a little bit because those straight lines ain't too bad. So let's start getting challenging for y'all. So here's a challenging one. F of x equals 6 over x plus 9. So y'all usually love fractions anyway. All right, so let me go to y equals and clear that. So to put this one in, I'm going to do 6 divided by, and then I'm going to put that denominator in parentheses and do x plus 9. Now remember, y'all can use the alpha y equals, and it'll give you that fraction option you can do and put them in just like they look on this screen, okay? So y'all see how I put that in? Now I'm going to show you the other way to put it in. So clear, you can hit alpha y equals, and I'm going to hit enter on ND because when I hit enter, it makes it look like a fraction. I can put in my 6 and then arrow down and do x plus 9. So y'all, that'll work either way that I just showed you, okay? So now we want to hit graph and see what this graph is about to look like. But y'all, let me tell y'all a little trick. All these graphs where they ask you to find the inverse starting at about number 7 on your homework, they're all going to be 1-to-1, okay? So let me graph. And you can tell that if you run this horizontal line down it, it's only intersecting that top part once everywhere. And then I got a little bit of that bottom part. It's only intersecting it once. So this is yes, 1-to-1. All of them are going to be 1-to-1, okay? All right, so since it's 1-to-1, we're going to find the inverse. So this is going to be a little trickier, y'all, but we're going to start out by replacing the f of x with a y. And then I'm going to switch that x and that y. So I now have x equals 6 divided by y plus 9. So now I will solve for that y. So I'm going to show you the easiest way. I'm going to put a 1 under the x to make that look like a fraction. But the easiest way to clear fractions when you got one fraction equal to a fraction, I'm going to cross multiply that. Okay? So I'm going to cross multiply x, this top, times that bottom. So that's going to be x times y plus 9 on one side. And then you take the 1 times the 6 on the other side. So cross multiplying eliminates fractions. The top of one fraction times the other fraction's bottom, and then the top of that fraction times the first fraction's bottom. Cross multiplying. And it only works when you got a fraction equal to a fraction, okay? Now let me show you something. What I'm going to do to this. I'm solving this for that y. So I'm not wanting to really distribute at this point. What I want to do is get this x moved. So y'all, can I not come in here and divide both them by that x? Because watch this. That x is going to cancel out right there. And if that x cancels out, all that's left is a y plus 9. Now on the other side, let's see what we got on top. 1 times 6 is 6, divided by that x. So y'all, let me stop y'all there. I want to show y'all a trick on that. Y'all see up here I had an x on the top left and the y plus 9 on the bottom right. All I did by cross multiplying, I switched places with them. The y plus 9 is now on top, and that x that was on top is now on the bottom. So you can do that all day long on these fractions. Flop these things around if you want to. Okay? So now, I got a y plus 9 sitting here. To get that y by itself, I need to subtract 9 from both sides. So I subtract 9 from both sides, bring down my y. These 9s cancel on that side. Over here, you cannot do anything with that. So that's just going to be a 6 over x minus your 9. Now, notice, I'm going to now replace this y with f inverse of x. And then I'll get 6 over x minus 9, final answer. So that's probably going to be one of the trickier ones because of the fractions in it. But they will work out, y'all, okay? All right, next we're going to do a cube. So how about f of x equals x to the third minus 8. So y'all, let me go back to y equals here, clear that. And I got x to the third, and then it was what? Minus 8. But we know these exponent 3s, these cubics are sort of going to be the little curvy graphs that go uphill. And y'all, it's hard to tell on these calculators, but that's not flat down there. That should be still going uphill a little bit, so that when you come down through there, that should still be, yes, 1 to 1. So we will find the inverse. So the first thing you want to do, replace the f of x with a y. All right, then I'm going to switch my x and y around. So I'm going to switch the x and the y. So I get an x equals y to the third minus my 8. So now we want to solve for y. So y'all, when you got a y3 sitting here, you want to get that y3 all by itself on that side. So we need to take care of that negative 8. So what I'm going to do is add an 8 to both sides. So that this side gives me an x plus 8 equals y to the third. So y'all, let me recall y'all on some information for this problem. So recall, when you got stuff with exponents, like an x squared, the way we solve x squared is we take a square root of that. That'll give me an x. If I have an x to the third, I would take a cube root of an x to the third. That'll make me an x. Y'all get an idea? So to undo exponents, we take roots, okay? Square roots, cube roots, fourth roots. We match that exponent with that radical, okay? So, since that's y to the third, we're going to take a cube root of both sides. So I know the right side, the cube root of that y cube, those threes basically cancel each other out, and all that's left is that y. So radicals and exponents cancel each other out. They're what we call inverses of each other. And y'all, unfortunately, I don't know what that x is under this radical, so I cannot go any further with that one. So that's going to stay a cube root of x plus 8. And then guess what? My last step, I'm going to replace the y with f inverse of x notation and just bring down that answer that was a cube root of x plus 8. So cube roots always undo your cubes. Your cubes will undo your cube roots if I get any of them, okay? So I guess this is bringing back all your equation solving memories from your past. All right, f of x equals 7x squared plus 2, and they're telling me x has to be greater than or equal to 0. Y'all, they are restricting my domain when they do that. So let me show you why they're doing that. If I was to put in 7x squared plus 2 and graph that, look what's going to happen. I get a parabola, which is not 1-to-1. But let me show you what you do. You see where they said x has to be greater than or equal to 0? You need to come over here where it says window, and you see where it says x minimum is -10. We need to make our x minimum be a 0. That's what they're telling us when they do that, okay? Now watch the graph. Oh, they only gave me half of the graph, which means that half of the graph is 1-to-1. So if they want a parabola to look like it's 1-to-1, they restrict the domain, and we don't count any of the negative x's. We're only looking at the positive x's, okay? So once again, that is yes, 1-to-1 because they restricted my domain. Now, if I want that back, I just hit zoom 6, and it brings it back to the regular graph. All righty, so replace the f of x with a y. So that's y equals 7x squared plus 2. Then I'm going to switch my x and y so that I get x equals 7y squared plus 2. Now, y'all, on this one, I'm going to tell y'all something. I'm going to write something here on the right side. This f -1 of x equals, it's got a square root and then a 7 on the bottom. They're giving me this much of my answer, okay? So it looks like to finish this out, all we got to do is figure out what's going to be on top of that answer. So this is what they're giving you. So let's get that out of this. So the first thing to solve that for that y, we got to subtract 2 from both sides. So I get x minus 2 equals 7y squared. So it's always counter moves, moving them around. Okay, so now, before I do anything with the y squared, I need to divide both sides by that 7 so I can get it moved. So the left side looks like it's going to stay x minus 2 over 7. On my right side, the 7's divide out, making a 1. So that gives me a y squared. So it's a y squared sitting there. Remember, we just said on the last problem, if you got a y squared, you take a square root of both sides. So the square root x minus 2 over 7 will equal the square root of y squared. Oh, y'all, guess what? You cannot do nothing with this side. So that's going to stay at x minus 2 over 7. But the square root of y squared is a y. So y'all, guess what? That's done. So replace that with your f inverse of x. And then that gives me a square root of x minus 2 over 7. So check this out. They gave you this much of the answer for this one. All you had to do was come in and put your x minus 2 on the top and be done. So y'all look, it's still continuing. They multiplied by 7. My answer was dividing. They were adding 2. My answer was subtracting. They were squaring. The answer took square roots. Okay? So y'all, one more and then that'll be it for this. F of x equals the square root of x plus 6. So this time it's going the other way. They're giving me the radical first instead of something being squared. So let me see. Go to y equals. To get that square root, you hit the second button and then the x squared button. It brings up a radical. And then I'll put my x plus 6. All right, so square root, let's hit enter. And it's giving me a little slightly increasing line, little curvy. But if we run our line down and it's only intersecting it everywhere once, so this is yes, 1 to 1.
How do we get our graph back to normal?
Oh, hit zoom in 6. So you'll see the zoom button on the top, in the middle, and then hit that 6 for standard. And when you do that, it should bring it back to a 10 by 10.
Okay, thank you.
All right, no problem. Oh, yeah, because, yeah, we had it resumed from 0 on, didn't we? Yeah. Or I tell you what you could have done, you could have hit that window button and then told that X to go back to negative 10 instead of 0. All right, y'all, so replace f of x with a y. So this is y equals square root of x plus 6. I'm then going to come in and replace or switch my x and y around so that I get x equals square root y plus 6. So y'all, I've been getting a few people on this one because they want to start out by subtracting 6 from both sides. You cannot do that. That 6 is under that radical there, okay? So anytime it's under the radical, you cannot do anything to it. So your first move is to get rid of that radical. So remember, if radicals undid the squareds, then if you had a square root of x, to undo that radical, you square it. And that'll give me my x. If I had a cube root of x, I would raise both sides to the third power to get rid of them radicals. So radicals got rid of exponents. Exponents get rid of radicals, okay? Now, the reason I'm squaring this, because remember, if these radicals don't have a number, it's automatically a 2 in that notch. So we're going to get rid of this radical by squaring both sides. So the left side, x times x is going to stay x squared at the moment. But on the right side, by squaring that radical, the radical is gone. And I end up with what was under the radical, which was the y plus 6. Hey, y'all, guess what? One more move and I'm done with this problem. And that's to take care of that plus 6 now. Now that the radical is gone, now I can subtract my 6 from both sides. So notice over here, you're going to get an x squared minus 6. Right side, the 6's cancel. All that's left is our y. All right, so I guess what I'll do is I'll do my f inverse of x notation and put in my x squared minus 6. So you started with a radical, you ended with an exponent. They were adding, we ended up being subtracting, okay? So y'all, that's 9-2, and the main thing on that was when you're finding the inverse, all you're really doing is switching those x and y's around and then solving for the new y when you switch them, okay? And then at the very end, MathLab will give you that inverse notation. All you're doing is putting in these answers on those, okay? All righty, so let me stop that share. And yeah, I recorded this, so what I'll do is I'll upload this into YouTube and I'll send y'all the links to it. And then that'll give you more examples of doing these, okay? All righty, y'all got any questions? So do y'all like this Zoom stuff? Y'all like that face-to-face? Well, we'll be back to 2 days next week, Cynthia. So Monday and Wednesday will be the only new lectures next week, so we won't have to use that Friday to come in on Zoom. But Carly, I'll still be on Zoom with you on Fridays, okay?
Okay, good.
All righty. So y'all, I'll let y'all go, and I'll see y'all next Friday then, Carly. Cynthia, I guess I'll see you Monday. All right, y'all have a good one.
Oh, well, I'll be there on Monday too.
Yeah, you can. Okay, that'll work then, okay? Definitely. All right, y'all have a good one.